Hello and welcome. We're going over another publicly available AP Physics 1 question. This has to do with work, energy, and centripetal force. We have a cart of mass 0.5 kilograms starting its motion. It actually has kinetic energy initial. The speed is 1.5 meters per second at the height of 2. It goes through the squiggly part of the track and ends up at point A, which is very significant for us, and that point A is a little lower than this top. So then we're going to have conservation of energy because they're saying that there is negligible friction between the cart and the track. Go figure. So kinetic energy initial plus gravitational initial should be equal to kinetic final plus gravitational final. Then kinetic energy final, which we're looking for, technically are looking for the speed at point A. In order to do that, we're going to express kinetic energy final through this UG initial minus UG final. So mv at A squared over 2 should be equal to m times 1.5 squared over 2 plus m times 9.8 and times 2 minus 1.9. So mass cancels. I'll multiply everything by 2 and root. So to get VA, I would have to do 1.5 squared plus, so this is 0.1, and I multiply by 2, so that's going to be 19.6 times 0.1, 1.96, 2.1 meters per second, so 2.1 meters per second. Question B, they want us to draw a free body diagram for the cart at the top at point, specifically at point A. At point A, it's navigating a turn that is circular, and therefore it needs to have centripetal force, otherwise it won't be able to complete the circular path. And that would mean that gravity is greater than normal force in order for your net force to be downward. C, we actually need to calculate normal force. Net force, which is mg minus normal force, equals net force is mv squared over r. So from here, force normal will be m times g minus v squared at point A over r. Plugging in our numbers, it's going to be 0.5 times 9.8 minus, at B it's 2.1, so it's going to be 2.1 squared over r is 0.95. Plug that all into your calculator, 2.6 newtons. They are offering us a scenario in which by the time it gets to point A, the cart just stops. And since there is friction, we have a certain loss of energy. How much energy are we losing? We are losing all the kinetic energy. UG plus K initial plus work of friction equals just UG final. Or you can do it even easier. What is that we're missing at point A? We're just missing kinetic energy. How much kinetic energy would we have at point A? mv squared over 2, and v squared is this one, and v squared is this one. So we could just do 0.5 times 2.1 squared over 2, and that is the amount of energy missing. That means that that is the amount of work done by force of friction, 1.1 joule. And then modify for loss of contact at point A. What they're talking about is acceleration this way. If you have V max, at which it's still in contact, but normal force is 0 because force centripetal is just mg. Usually, force centripetal is mg minus normal force. As normal force gets lower to 0, your F centripetal is just mg. That is the maximum possible speed. Any faster and it will lose contact. How do we increase V? Increase V initial. Increase high initial. Another way. Decrease height and r right here, and that would create a greater V, which would mean that F centripetal is more, F required centripetal is more than available mg, so it flies off. There you go. That is all our work from A to E for this lovely question about a roller coaster of some sort. If you have any questions, post them in the comments below. If this was helpful, like, subscribe, be kind.